Today we are going to discuss about, in this session we are going to discuss about the GAN. Here the word generative is started with this concept only. Actually we have the generation of the data. Already we have the generation of the data. We are generating the data. Already you generated the data. Where did you generate the data? Autoencoders, yes, you generated, but other than the autoencoders, you have already generated. In RNN, what are you doing? Are you generating or not? You are predicting the next word, and based on that you can predict the next word. Meaning that you are generating the text, and in the autoencoder you are generating the image, right? So the word generative is using now, but the concept exists long back. Generative, it is already there from 50s. The generative concept is existing from 50s, not now. It is not a very new technology, right? Now we will start with the concept, and of course we will go with the generative AI, what is generative AI, and then motivation for the GAN and GAN concepts, components, and how to implement all these concepts. We will go through that. So I will try to explain some code part also, and I will try to execute the program also, right? And now generative AI. You know AI. AI, artificial intelligence. Here you have to understand one point here. I think in the first session only we discussed about this. The difference between the AI, machine learning, deep learning, and generative AI. These are the various steps. And of course data science and big data, they are also another wings for this. So artificial intelligence, it is full of algorithms. Simple, very simple. It is the concept of algorithms, how to handle the data and how to build the intelligence, artificially. For that data is required, but it doesn't deal with data handling. It doesn't deal with how to store the data and how to process the data and all. It doesn't deal with that. It deals with only algorithms. So it is like the mathematical way. And even if you have the mathematical way algorithms, if you want to convert them into the programs, like by using the C, C++, Java and other languages, it takes a lot of time to build the program, and also the CPU power for most of the advanced algorithms. Why it has taken this much of time to develop all these concepts? Because of the computation power, lack of computation power. We have algorithms, but we don't have sufficient environment to run those algorithms. We have bullet train, but we don't have the proper track. What can we do? No. So that was developed now. So because of that reason, now we are in the AI era, right? So see here, artificial intelligence, as a part of that, the subset, we can say that it is the subset. We can call it as the machine learning, and from the machine learning, another part, one kind of machine learning algorithm is the deep learning, right? In the machine learning, we will use the statistical methods, most of the statistical methods, and gradient descent was also introduced, and so many algorithms are introduced. And deep learning, we will go in depth. In the last session I have explained how the machine learning to AI, artificial neural network, how we have transformed. And then deep neural network, deep. If you increase the number of layers and number of units, we will go into depth. So that is the flow. Okay, and then now again in the deep neural network or deep learning, we have another way, one subset of the deep neural network. We can say that it is the generative AI. We can say that it is a subset, and you please remember that not only the part of the machine learning is not only the part of artificial intelligence, it is a part of statistics also. And deep learning, it is not only the part of the machine learning or artificial intelligence, it includes so much of mathematics, right? In the similar way, generative AI, it is also related to so many other factors. But our perspective is from deep learning. Our way is through deep learning. That means that there is no other way. That it is not meaning that there is no other way. There are so many ways to reach the generative AI. But one of the way and popular way is deep learning. Right? And now, domains. What are the domains of the generative AI? First of all, what is generative AI? To generate the data. What kind of data you can generate? You can generate the text. You can generate the images. You can generate the videos. You can generate the audio. And there are so many things in the fashion designing. And the scope is vast. And everywhere you can use it. And even in the cricket match, is it the effect of cricket match, India-Pakistan? I think so. Right? So, even in that, in the replay and animated pictures, if you observe that, animated pictures, they are generative only. How he hits the six in the replay, and in some matches I have seen that the animated, how he played. And ball tracking, I think you can see that LBW. In the LBW, what is the ball tracking? All these are through which includes the machine learning, deep learning and generative. In some parts, generative AI is also useful. Right? Imaginary, you can do the imaginary things. Right? And what we can generate by using generative AI? Text, image, music and video. This is the scope as of now. I am not saying that it is only the scope. This is some scope of generative AI. You can generate so many other things also. Right? And mix of these. And now, text generation. What is the text generation? Already you have seen that text generation. In RNN, you are generating the text by using RNN and NLP. In NLP, so many techniques are there. Actually, NLP is not the machine learning. The combination of NLP plus deep learning, it will give you more power. That is the transformers that we are discussing as the part of this workshop. And text generation, the text generation of the text. What are the applications? You can develop one poem, as Sir said the last session. We can develop the articles. We can design the article. If you give some inputs, you can get the article, complete article. I am very poor in writing the papers, journals. So I can give my idea so that it will generate the paper and give it to me. I have so many thoughts in my mind, but I'm not good in the English or some literature. I'm not good in literature. But if I give my thoughts, that will generate the poem, that will generate some story, a very good story. And in future, the future of AI is There is no need of directors, there is no need of music directors or fight masters, nobody. There is no need of anyone. Simply you can give the story. Story is also generated. You can generate the story. The AI will generate the story. The AI will generate the hero and actor, actress and all. And AI will generate the music. It will compose the fights and everything. And visuals, everything. So no need of anyone. You can generate the complete animated picture. And in future, very near, we will have that. Okay, so in that, as a part of that generation of the story, generation of the poem, it is also the effective thing. And GPT, chat GPT, and I don't want to talk much about the chat GPT because this is included in the next sessions. I don't want to talk about that. Generation of the text. As the part of that, you can generate the poems, you can generate the stories, and you can generate the product descriptions also. Any product description, if you have some product, let us say for example, that projector is there. How the projector is working we know. But if you want to generate the description about that product, actually technical writers are there. I think you know or not, I don't know. Technical writers, they will write about the product. If a company designed one product, before releasing that, manual is there. For that manual, there should be some technical writer to describe about that product. That will be also done by AI. Right? And image generation, this is our part. Image generation. Here, the image generation, generative adversarial network, and it was introduced by Goodfellow, and he has written one textbook also, so many textbooks also there, some textbooks, deep learning. Okay, if you go through that textbook, you will enjoy really, but it is little difficult to follow that. It is not an easy book. Okay, so he introduced that, and the purpose of the GAN is to generate the images. It will generate the images with noise, meaning that there is no base. Without any base, it will generate the images, and it will compare with the given original images, and it will improve the generating the images perfectly, right? And some more concepts are also there, that is OpenAI DAL-E. I think Sir explained about this DAL-E in the last in the introduction part, right? We can generate the images if we give some sentence. Based on the sentence, it will generate the images. And in between these two, there is another concept that is called the clip. One more concept. Actually, all these are the DAL-E and clip. All these are the mix of the sequence and this image analysis. Okay. Now, music generation. Another one is music generation. Music generation is also started long back. Okay, and those tools are there. And some architectures are there like WaveNet and Magenta project by Google. These are the various tools. And from the OpenAI, of course, if you want to generate the music, again it is a series data, because the sounds are in the sequential form. Okay, now that is also by using the RNN and machine learning techniques. And OpenAI, it introduced the jukebox. It is also music generation software, right? And video generation, DeepMind's motion to video. So meaning that it will take some set of images and it will generate the image, it will generate the video. Like GIFs, we are creating GIFs, right? How we are creating that? Sequence of images. If you take the sequence of images and combine them, you will get some video, GIFs and small videos. You can use them. Okay, and video to video synthesis. It is also another one, vid to vid, and it is also deep learning based model. And The generative AI, it is traveling through like this. It was started long back actually. My screen is not sufficient to show that. So I started from the 2014 only. From 2014 at that time, NLP is also old concept. From NLP, transformers and all these are LSTM, GRU, and you can see that, yeah, LSTM. You can find some of the concepts in this workshop. I don't want to explain each and everything. You just have a look where we are. See here, it is in the 2014. There, LSTM we discussed in the last sessions, right? And again, VAE. And then we have different versions of GANs also there. I am not going to discuss about all of them. I am going to discuss about the basic GAN concept, right? And we can go with the BET. BET, I think tomorrow we are having the class, right? BET session tomorrow. Okay, and GPT-2, that is also tomorrow we are having this. These two are there. These are the NLP based, and we have some more concepts like GPT-3 is also there, and T5 is there. Clip is here, and then DAL-E. These two also we are trying to cover. Okay, we'll see. And now, see this. Who are they? They're actors, are dynamic persons. Can you recognize any one of them? Can you recognize? Who are they? You cannot recognize? Huh? Can you recognize any one of them? There are so many pictures are there. Dynamic persons, they are looking like dynamic and beautiful, and so many pictures are there. Anyone can recognize them? I cannot recognize because they are not original images. They are generated by GAN. They are generated by GAN. They are not here. They are not real images. They are not real people. They doesn't exist. They are not here. They are generated by AI, that is GAN. This is the application of GAN. You just imagine how it has generated. So, generating the new hero is also not impossible. Right? So, we can generate like this. If you want to train like this, it is very difficult. You should have the proper environment and proper hardware. Software, we have software, no problem. But the hardware is important, and you have to tune the model. You have to tune the models. You need not write the model completely. You have to tune at least. Tune the models and train them properly. That is your requirement, right? And now, come to the concept, GAN. So here, you may think that it is repetition. You just see this here. Already we have the CNNs, and CNN we are having the convolutional, and then we are having the dense. From the dense, we are classifying the images, the data points, right? That may be by using softmax or sigmoid or by using any one of the algorithms. Actually, this kind of algorithms, if you are classification, the classification algorithms, they can call as the discriminative model. We will call them as the discriminative model. Meaning that we are classifying, right? And next, you know this, autoencoder. They are what are they? They are the generative models. This is generative model. You know the discriminative model and the generative model. Both you know. You know both. Generative and discriminative. Discriminative, our traditional machine learning. Most of the machine learning algorithms are discriminative. And generative, we have seen that. Autoencoders, variational autoencoders, right? And now I want to combine these two. Both are powerful. I want to combine these two. How can we combine them? And why should we combine? The first thing is, if you use the variational autoencoder, see here, you can see the picture and this picture. Is it visible? Is it visible to you? See this picture and this picture. We are taking this picture as input, we are generating this picture, but it is blurred. It is not clear. Even if you give a proper architecture of VAE, you cannot get a complete clarity picture. At least there will be some blurriness. At least some blurriness will be there with autoencoders or variational autoencoders. Definitely. Because we are taking the variance, we are taking the variance vector also. So based on that, we will get at least some variance and some blurriness. Blurriness because of the variance. Why we are getting the blurriness? Because it is not pointing a single point. It is not taking a single point. It is taking the surroundings also. So that obviously you will get some noise or some disturbance. That is the blurriness. That will give you blurriness. Okay. And if you want to get these type of images with autoencoders, you may not get it. So what we have to do? The thing is, the discriminative analysis or discriminative model, it can exactly classify whether it is good or bad. It is having that power. Am I correct or wrong? We have the power of discriminative analysis, whether it is good or bad. Whether the picture is good quality picture or bad quality. This is possible. And by using the generative model, we can generate with some noise. If you combine these two, the generator that can generate the new image and the discriminator, it will tell, no, this is wrong. This is not what I am expecting. So you have to improve your model more. You have to train your model more. Then the generator again go back and train and then again generate the new picture, and again that will be given to the discriminator. Again it will classify whether it is good or bad. Hope you understand. Right? So this is the basic concept of the generative model. Now, generative modeling, we can say that it is the unsupervised because we will design the imaginary things. We are not going to design the existing things. We are going to generate the imaginary. It doesn't exist in the real life. We are generating. So we can call it as the unsupervised. We will not have the output variable before creation of that particular image or video. We will not have that previously. Right? And now, generative adversarial network. Here, the name itself will tell you. Adversarial, meaning that opponents. We will have the opponents. I am trying to generate, someone will stop. No, you are wrong, you are wrong. I will generate, someone will say that you are wrong. Even for preparing this PPT also, I will cross check with number of faculty. Yes, I have generated this. I will take the feedback from all the faculty, my colleagues, and based on that again I will revise that. Again I will revise that. Because of that reason we will get the good quality pictures, good quality products. So we have, every time we have to take the feedback. There should be an opponent. If there is no opponent, monarch. Whatever I am saying, that is the rule, that's it. There should be some opponent. So, generative adversarial network, to generate the model, see, there should be two networks required. One is to generate, second is to point out it is wrong, it is right. Two networks are required, the generator and discriminator, two concepts. Now from VAE, already we have the VAE, variational autoencoder. Please have a look on this. You have to observe this. We have the convolutional neural network. From that we have generated the mean vector and variance vector, and we are creating a sample in the latent space, and then we are regenerating from that latent vector. Clear? What is our concept here in the generative model? In the GAN model? I want to generate from noise. Where is noise here? In this entire image, in this entire architecture, where is the noise? Here. It is the random. Random noise is here. From here, we are generating this image, and of course we are taking the support of this, the mean vector. Sometimes it may be the advantage, or at the same time it may be the disadvantage also. It will restrict to generate freely. It will restrict. This vector, it is stopping me to generate the proper pictures. So what can we do? So the architecture is changed like this. See here. Whatever we have this vector and this entire generative model, we have taken back, taken separately. See here, we have this variational autoencoder, we have taken the variational vector, variance vector, and the generation process, we separated that from the architecture. And from here onwards, now see here, and that can be used for classification, because already we have the dense, here, so we can simply add the classification real or fake. What is fake, what is real? Here you have to understand, this is very important. In so many papers, while reading the GAN papers, definitely you will be confused with real and fake. Real means the original image, that is okay. Fake means it is not only fake, the noise is also fake. Randomly I am putting some dots and giving that, it is a fake. Right? So the fake, real or fake. Here I am creating the fake image, and here we are taking the original images and classifying. Here this model, I want to classify the given image, whatever the image is given, whether it is real or fake, I want to classify that. For that I am using this model, first part of the model. Second part of the model, this part, I want to generate the image from noise. From noise I want to generate. Noise in the sense, from random. From white paper, I will give just white paper. On white paper I want to generate this. Hope you understand. Now this is called the discriminator because it is classifying, and this is the generator. Here it is generating the image from the vector. So two parts are there, discriminator and generator. Now you see this, I am taking these two separately. Now you just observe, here is the key point, please listen carefully. See here, this is the discriminator. We have to train this discriminator to classify the given image as the real or fake. To do that, this is supervised or unsupervised? This is supervised or unsupervised? Discriminator. Supervised or unsupervised? I have to give one picture and my network has to identify whether it is a real or fake. whether the dog is present or not. Supervised or unsupervised? You are learning generative AI. And you have completed machine learning already. I have two pictures. And I want to classify what are those two pictures. Is it supervised or unsupervised? Classify, classification. I am giving the word also. Classification comes under supervised learning. It is supervised only. Right? Now, here for the supervised, please think that we have the real images. This is okay. What about the fake images? We have to provide the real images and also fake images to get trained the discriminator. We have to get the fake images also. So where should we get these fake images? One means real image. Okay, it is okay. So many real images are there. Right? Now, what we can do? We have to train. Okay, that we can think later. First, let us train this model. These are the real images. It is generating the fake images or generated images. Now, I want to train this model, discriminator training, that is by using the simply cross entropy. Simply cross entropy, by using the cross entropy. This may be the binary cross entropy. Generally, it is a binary cross entropy. Right? Why? Because two classes only, real or fake. Now, this is okay. Now, here to get trained, if you give only real images, I am having only real images, so that it can be trained, meaning that it is completely imbalanced data. If you think about this, it is the completely imbalanced data, because all the images are real images. There are no fake images. All are one. Now what should we do? We have to add the fake images. Where will we get the fake images? Here already it is generating. I have another part, generator. The generator is generating the fake images. So I can take the fake images from the generator output. I will take this generator output and I will train this discriminator to get trained. Hope you understand. Right? So this training is okay. Now, from random it is generating the image. From random it is generating means white paper. I have given this vector means it is white paper. All are ones, meaning that white color, completely white color. On that we are giving that to generator based on the decoder, same decoder part. Like decoder, it is generating the 28 by 28 or 128 by 128 some image. It is generating some image. That image is blurred image, that's it. There is no shape. For that there is no shape, nothing. Right? So shape is there, but there is no meaning of that image. So some random picture is there. Right? If you see that back side, you have a good painting. Can you tell me what is the meaning of that? Now, I am not talking about the Swami Vivekananda. I am talking about the background. Or, you can see that here also. Here there is some pattern. Like this, something will be generated. Definitely it will be the fake. So, first we will give this also and get trained, the discriminator. Later, I have to improve my generator to generate the images looking like this. I want to generate the images looking like this. So, this has to be trained. These weights have to be modified. For that, I have to train the generator. So, I have to train the generator. This is also by using cross entropy. Again, this is also cross entropy. Why? Because for the discriminator, you just see that for the discriminator, input is the image, output is real or fake. And for the generator, The input is the random vector, that is a latent space. Latent space, we can say that it may be 100 or 200, like that we can take. From those 200 random values, we are generating and we are passing through the discriminator, and here it is again classifying this. So again coming back, here what is my target? I want to make it 1. I want to make it 1 in the sense here 0 1. I want to make it as real. Even that should get confused. The discriminator should confuse that what is the real, what is the fake. So what I have to train? Generator has to be trained. Generator has to improve. What about the discriminator? Discriminator initially it has to train. Next again the generator is generating the good images, and still there are some problems. For those problems again it has to improve. Based on the generator performance, again it has to improve. And we are conducting one exam. Let us say for example we are conducting one exam. In the first exam we have conducted simply by by placing all of you like this only. First time. So randomly we conducted the exam. First time what we got is, everyone is getting good marks. So next exam, we will skip one chair. We will leave one chair and we will arrange the seating like that, so that we will get good performance analysis. Next time what you will do? You will find the solution, how to get the marks. Next again we will learn how to solve that, how to control. Again you will come with new techniques, how to get the good marks. This fighting will be continuous. The same model here. Here the discriminator always try to say this is fake, this is fake, this is fake. The generator will always try to make it, no, this is the original, this is the original. It will try to improve the quality of the image. Right? I hope you understand. So here you have to understand the important points here are the discriminator should be trained and the generator should be also trained, and both have to train continuously. At a time, once if you train the discriminator, you cannot leave it. You have to improve it again and again. Once if you train the generator, it is not enough. Again you have to train. Here also you have to take care about the discriminator. Here also you have to take care about the discriminator. It should not be modified, it should not be changed. Right? So, how it is? Let us see. Here, a small example. See the same, whatever I have given the example. The fake currency. The fake currency, see here, there is a printing press and there is the raw data, raw material, that is ink and papers are there, and they are generating the currency, and the police, they will verify whether it is a fake or real. It will verify, and first time they can catch. They can catch first time. Next, immediately based on this feedback, what they will do? They will try to improve more. They will try to generate good currency. You cannot identify that. Okay, next, this will be continued. See, you can see that generator, discriminator, generator, discriminator. First, the discriminator, it will try to identify what is the real, what is the fake. It will have some knowledge, and the generator, it will try to generate the fake currency, and again the discriminator, it will try to classify that it is a fake. Whenever it is saying that it is fake, again the generator will alert and it will generate the new, again another fake note, and it will That will be again verified by this, and this will be continued. If the discriminator is trained only once, the improvement of the generator, it cannot be handled by discriminator. So once the generator is modified, once the generator is trained, the discriminator should also train based on that. So it should be the cycle. Please remember this point. Hope you understand. Are you getting? Are you getting? Are you getting the subject or sleep? Are you getting the concept or sleep? Sleep. How many of you are getting sleep? No sir, all of us are in sleep. We cannot raise our hands. Okay, so this is the concept of generator and discriminator. This concept wise it is okay, but for implementation you have to see that how it is. Okay, now you can see that so the same architecture, again and again the same concept. Discriminator, generator, discriminator, generator. Discriminator, it will take the real images, discriminator network and predict the labels. Generator will generate the images, fake images, and continuously giving to that, and it will be continued. I don't want to waste much time. Here is, see this noise. In this picture you have to observe this noise only. See here, from noise we are generating this, and real images they are giving to discriminator, real or fake. Again it will be trained. See how beautifully it is designed. Now where should we take the output? If you want to take the output, where should you take? Where should you take the output in this entire architecture? We are seeing that this is the actual output of the entire architecture. Am I correct? What is that? Real or fake? That's it. What will we get? If you get that output, whether it is generated real or fake, that's it. But what should we get? We want to get that fake image. So we have to take the generator output. If you get the generator output and display, then you will get the picture. If you take the final output, you will get whether it is fake or real, that's it. There is no use. So please prepare your mind to get the output, from which location we have to take the output. Till now we have the algorithms, very simple algorithms. We are giving the input, at the final stage we are getting the output, that's it. But here we are having multiple outputs. One is the image, another one is real or fake. We have to take two, right? And now components, of course, generator, discriminator and loss function. We have to understand these three. Okay? Yeah. Generator function. What is the generator function? As you have seen, generator function, it will generate the image from the random sample. We will take the random sample, generator network. First, what we have to do is, we have to build a network for generator. How you are generating, that is your wish. In the original paper of GAN, they have used the artificial neural network. That is the ANN, dense layers. All are dense layers only. But if you are using the convolutional layers, then it is the deep convolutional GAN. Actually, the GAN is replaced with DC GAN, deep convolutional GAN. Okay, most of the GAN applications are developed based on the convolutional layers only. Okay, nobody is using artificial neural network, that old artificial neural network. Everyone is using the convolutional. Okay, and so see here, generate the network and the discriminator. After that we have to design the discriminator network and then discriminator output, and we have to develop the generator loss and discriminator loss also. Generator loss, what is the generator loss? What is the generator loss? Generator loss is only, what is the discriminator loss? Discriminator loss is only very simple. The categorical cross entropy, binary cross entropy, that is enough. And for the generator, you have to consider the generator architecture and also the discriminator architecture. Hope you understand. Now here again one hidden point. There is one hidden point in this concept. Most of the developers are leaving this point. Because of that reason they are not getting the proper outputs. The thing is, see, we are the back propagation, by using the back propagation based on the loss calculated, we have to update the weights. Am I correct or wrong? We have to update the weights, W1, W2, W3, those weights have to be updated. Clear? Now, if you train the discriminator, you can modify the weights of discriminator, there is no problem. What is the back propagation concept? It has to adjust the weights based on the outputs, original outputs and produced outputs or calculated outputs. So it will always modify the weights. In the discriminator there is no problem. In the generator training, if you leave the discriminator to update the weights will be updated according to the fake image. The weights of discriminator, there is the danger of updation of the weights of discriminator with the fake images, according to the fake images. So we have to stop that. Meaning that while training the generator, you have to freeze the discriminator. Meaning that you have to make the discriminator as untrainable. You have to make all those layers untrainable, meaning that the weights should be freezed while training the generator. While training the discriminator, it has to be free. The discriminator, while training the discriminator weight should be released. And while training the generator, the discriminator weight should be freezed. So this point is very important while developing the application, right? And of course the heading, don't see the heading, it is not generator, it is completely GAN architecture, how to develop the GAN. Now see here, generator, as you know, see here, as I said to you, random input generator, it will generate the sample or image, and from that the discriminator will take and generator loss will be created. What is the generator loss here? The generator loss includes two parts. Here discriminator loss is already created and plus this one also. This should be also considered. So see here, in this generator model, you have to consider the loss for discriminator and total loss also for the back propagation. So generator loss includes both the generator and discriminator also. The discriminator loss, it includes only discriminator loss. Only discriminator loss. Hope you understand, right? And now, discriminator training. If you want to train the discriminator, then you have to give the real image and fake images. Real images from the data set. Fake images are from where? Fake images from the generator, right? And you have to prepare the data set and give that. And then discriminator training. In the discriminator training, you have to give the random sample, random vector, and go through it and calculate the loss and come back. Okay. So this is the training of the generator, but as I told you, you have to freeze the discriminator while training the generator. Today you have to execute the program, complete a program. Okay. And how it will be? The discriminator trains for the one or more epochs. How we can generate, how we can train the model is, you have to run 2 epochs. Let us say for example 2 epochs for discriminator, train the discriminator 2 epochs, and 2 epochs generator. 2 epochs discriminator, 2 epochs generator. And when generator is coming into picture, freeze the weights of discriminator. So this is the way of training the model. And loss function actually there is lot of stuff inside the loss function. Simply what we can say is the binary cross entropy is the main part of this, because fake or real. Of course there are so many other points also there, but basically it is the fake or real. Now we will execute one program on this. Okay, if you have the laptops, you can open them and you can open my code. GAN program is there. Please open it. Please open it. While doing that, you just have the applications of the GAN. Then why should we generate these pictures and applications? Is there any use? Is there any use of creating the fake pictures? Is there any use of them? If you, yes? Tell me, Parol. Yeah, okay. So, see, autonomous cars. How many of you heard about that? I think most of you. Autonomous cars, meaning that driverless. Without driver, you can go by car. For that, actually, these kind of training will be done based on the reinforcement learning. Reinforcement learning is like trial and error, meaning that you have to leave the vehicle on the road, and if it hits something, some object, then it will learn, oh, there is an object. Next time I should not go this. Can you leave the car like that for training? Is it possible? If you leave that, then you will go somewhere. Right? So because of that reason, we should have the simulated pictures. Simulations. Meaning that fake pictures, we need the fake pictures for training. If you go this direction, what will be the output? If you go this direction, what will be the output? Like that, you have to generate the simulated pictures. For that, GAN is useful. And sometimes you may not have the sufficient data for some situations. Let us say for example, I want to fix one camera here and I want to predict the crime is happening or not in this campus, in this place. When it will be happened, when we will classify that as a crime. We have to wait for crime to happen. When it will be happen. So it is very difficult. So what we can do? In the signal jumping, it is very easy to track. So many signal jumpings will be there. But especially a crime, the crime generally, in general it will not happen. Sometimes it may happen. So if you want to identify that, we have to generate that picture. There is no option. It will not happen really. It may not happen really. Even if it happened, that may not be recorded. There will not be any evidence of picture. Right? So because of that reason, in those situations, we have to generate the fake images. Right? And see this, all these are the examples. You can see there, these examples. And Human faces also, you can generate the human faces and realistic photographs and cartoon characters, emojis and cartoon characters. For every one of, I think already you have done with that. You played with that, with Facebook, and so many applications are there with Facebook and Instagram. There are so many pictures. If you give your picture, your cartoon picture will be generated and give it back to you. For that, that is also there by using this. Okay? And clothing translation, video prediction, and photo painting. And then face aging, meaning that after 50 years, how you will look like. All this will be possible by using this. It will be generating. Okay, so many are there. And the GAN is very powerful, and it can be used in the another applications also for advanced vision language systems also. For them, vision language models, we are using the GAN as the internal part. Without GAN, we cannot do that. Even for the clip, even for the, not clip, DALL-E and all. Wherever you have to generate the new images, there you have to use the GAN. So this basic GAN you have to understand. Please go through it. Yeah, please open that program. Discuss about the implementation of the simple GAN. Okay, you can do the experiments also on that. If you download the program, I mean, if you add that program to your profile, you can do some experiments. Okay, if you observe in that program, I have given 2 data sets. I have added 2 data sets in that. First, let us try with one data set. After that, you can change to another data set also. Yeah, basic data set is flower data set. That flower is also generated flower, the animated flower, I think. It is not original flower, animated flower, right? So what should we do is, we have to normalize the images. Normalize in the sense you have to read, and you have to normalize that to 0 to 1. And here one more important point. Here most of the standard algorithms are having the activation function as tan H. Okay, it is not ReLU. Why? Because the ReLU will give you a very big number, it may give very big number, so that it may exceed, and gradient explosion may be there. So because of that reason, generally we will use the tan H. It is because it is in between -1 and 1. So our images are, what is the value of the image? I mean the cell values of the image. What is the cell value? What is the image? Collection of pixels. What is a pixel? Basic unit, okay. What it is having? What is the content of pixel? 0 to 255. It is the black and white image, meaning that grayscale image. Then there will be only one value. If it is a color image, then 3 values will be there, R, G, B. The intensity of the color, the intensity of the red, intensity of the green and blue, R, G, B values. So what is the range of that color? Range of that pixel? 0 to 255, because we will take that as unsigned integer. In general, we will take that as unsigned integer 8-bit. 8-bit unsigned integer. So 8 bits will be there. All those 8 bits will be used for the data only. There is no sign bit. So 0 to 255 will be there. If you give the input 0 to 255 into the gradient descent part, then it will perform so many operations. Because of that reason, it may give you very big number. So better to scale it down from 0 to 1 or -1 to 1. You can make it as -1 to 1. Right? If you want to make it -1 to 1, that is also scaling. That is also comes under the normalizing the data, normalizing the image. Okay, after that, create the generator and discriminator networks. We have to generate the networks for generator and discriminator separately, and then loss functions, define the loss functions, and then we have to go for the training both the models. Right? Now for that, right now you can open the program and see that, and on screen it will be little different. Right? You can see that here. Now generator model. See here the generator model. What is the generator? What is the architecture of the generator? What should be the input? What should be the output? For generator model, there are two parts in GAN. One is generator, second one is discriminator. What is the generator part? What is the input for generator part? Random noise, or it may be the vector. It is a vector, random vector. We can take the random vector, that is latent space. The latent space size, we can give the latent space size. That may be 10, that may be 100, that may be 200, or whatever. You can give the latent space size. So randomly it will take. What is the output of what is the output of generator? What is the output of generator? Image. So image of size what? Which size? Image of which size? That we have to define. As a developer, you have to mention. What you have to mention is, first is, what is the size of the latent vector? That you have to mention. Second is, you have to mention the shape of the output. You have to decide what is the shape of output. Based on this, you have to adjust the discriminator also. You have to define the discriminator also. If you generate 255 by 255 image in generator, and in the discriminator if you are handling a 28 by 28, then there will be the incompatibility between the generator and discriminator. So your model will give the error. And at this stage only, you have to decide whether you are using the grayscale images or color images. If it is a grayscale image, there will be only one channel. If it is a color image, 3 channels will be there. All these are very simple points. You may think that why he is repeating number of times. See, I will give you a small example. Actually, I have created the program. I have done this program, I think 2 years back. After that, I don't remember that at some time I have changed, or I don't know whether I changed or not also, I'm not sure. But 2 days back, anyway it is completely executed program. 2 days back I tried to execute it again, but it was not executed. I struggled for 1.5 days to find out what is the problem. Do you know what is the problem? There is the difference between the number of channels in the discriminator and generator. That is only the problem. I struggled a lot for 1.5 days. I am getting different errors. Why I am getting this? I am not seeing that, because I only created the program. I know that these two are the same. When I have changed, I don't know. I don't remember actually. Right? So because of that reason, this is very important. Now you can see that you have to keep it in mind, the input size, output shape, and another important point, the number of layers in between, how many layers you are giving. Once if you decide what is the input shape, output shape of the generator, you have to adjust your network according to that. In network, if you are using the convolutional layers, convolutional transport, conv2D transport, then in that there will be the dependency on the layers. What is the layer you are using? Based on the previous layer, the image will be generated in the next layer. So how many layers you have to place, that you have to think. The main point is input and output. Once if you fix, you can include any number of layers, but the condition is your output should be with the same size, same shape. So you can observe that first layer, I am adding the first layer here, randomly I am taking that. First layer I am taking 4 into 4 into 512. 4 into 4 into 512, meaning that I am taking very big latent space. Latent space is very big. Generally we will take 100 or 200. I have taken very big size, and then I am reshaping it, and then dense, we are using the dense, and then reshape, I am using the reshape here. After reshaping, actually one more thing here. In general, avoid ReLU. In this code, ReLU was given. ReLU sometimes it is okay. But please remember that our output for the discriminator is, what is the output for the discriminator? That will be 0 and 1, real or fake. And if you are going through the ReLU, and there may be the problem, so better to go for the tan H. Tan H activation, always better to go for the tan H in most of the cases. Okay, sometimes you can try with ReLU also. So here in this example we have given the ReLU. After that reshape it. I am reshaping it with 4 by 4. 4 by 4 and how many? I am taking 4 by 4 and 512. I am taking 512. 512 features. 4 by 4 images, I am taking the 4 by 4 images. How many images I am taking? 512 images. Randomly I am generating. Right? After that. And then reshape it, and then Conv2D transpose. We are upscaling that. And now 256. How many I am creating? In the next level, I am creating 256. 256 features. From 512 features, I am going with 256 features. And I am upscaling that. And the kernel I am taking, actually this generally we will not take 4 by 4. And strides is 2, meaning that double the size. We are making it double the size. Meaning that we are every time we are increasing the size of the image and decreasing the number of features. And finally, you can observe that we are adding the number of layers, and then finally we are getting at the last layer I am getting 3. Why I am giving 3 here? Please observe that last layer I am giving 3. Why I am giving 3? Why I am discussing about this is, you need not write the code from scratch. At least you have to take the code from somewhere, and at least you have to modify it. You should be able to modify it. To modify that, you should know these points. I am giving the output as 3. Conv2D transpose of 3. Why I am giving 3? Anybody can tell? 3 layers, 3 images, meaning that 3 layers I have to generate. 3 features, red, green, blue. Right? So 3 images. And of course the kernel size I am giving, and strides 2 by 2, and finally we are getting some size. This size you have to adjust according to your fixed size, what you have fixed. What is the size it is generating, I don't know at this moment. I have to calculate from starting onwards, all the layers. And you can observe that in between we are using the batch normalization. This is optional, whether you can use or you may not be used. You can or you need not use batch normalization, because every time we are normalizing the data. In every layer we are normalizing the data. In a very simple way, how you can generate the generator is, how you can build the generator is simply by adding this conv 2D transpose and then conv 2D transpose and then conv 2D transpose, that like that you have to use that is enough. And activation also you need not give that as a separate layer. Activation also you can include as the part of the conv 2D. Activation equal to, you can give that. If you want to give any special features, then you have to use it. Clear? So this generator, it is taking some latent space and it is producing the color image. Please remember that it is producing the color image. And then discriminator model. Discriminator. See, what is the discriminator? What it is taking? What is the size, input shape? This input shape I am giving 64, 64, 3. What is this meaning? 64, 64, 3. 64, 64, 3 input shape for discriminator. You imagine the discriminator in the diagram. In the discriminator, the input is image. For the discriminator, input is image. Which images? Real images and fake images, both. You have to combine these two and you have to give that as the input for discriminator. And that image is 64, 64. 64 by 64. And how many 64 by 64 is the input. And from that, how many images you are giving? We don't know. How many images you are giving? We don't know. We will not specify that how many images you are giving. For that, in the model it will display as none. If you display the model, it will display as none. Meaning that at that place, whatever how many images found, that number will be taken. And the size of the image is here 64 by 64 I am giving, and I am applying the I am creating the 64 features. After that, again I am going with the, and now dropout layer, I am using the dropout layer of 0.3. What is that 0.3? This is also optional. Dropout layer is also optional. Why I am using, what is this dropout? It will drop some features randomly. How many features have to be dropped? Actually, how many features generated here? 64. Out of 64 features, 0.3 means 30%. 30% of 64. What is the number? I am very poor in mathematics. Tell me. Please calculate and tell me. 19 point images we cannot remove. 19 images it will be removed. 0.5, 0.6 images we cannot remove. So 19 images will be removed. 19 features will be removed. Right? So, and how many features are left? Nearly 20. 20 images will be removed. 20 features will be removed. How many are left? 44. 44, roughly 44. 44 images. From that again I am giving the convolutional, and how many images again I am creating? From that 128 images, 128 features I am generating. And then I am giving next dropout, again dropout 30%. Again 30% I am removing. So in 128 30%. And then finally flatten and dense. Dense of 1. What is this one? 0 or 1? From 0 to 1. Right? So this is the discriminator. You can easily create the generator and discriminator, but the combination is very difficult, because here you have to remember what is the input shape you have given, and this should match with the output of the generator. According to this you have to adjust the generator network. This is important, right? And then Next, discriminator loss and generator loss. Discriminator loss. How can we get the discriminator loss? Discriminator and generator. Here the output, the input is not from single source. It is from two sources. One is from real, one is from fake. Two sources are there. So you have to take from two places and you have to combine them, the loss. Right? And cross entropy, we are using the cross entropy of these two. Real output and here we are calling the discriminator of that real output and original output. These two we are giving, and again cross entropy, we are using the cross entropy for the fake images, again we are giving, and we are adding these two for the total loss. Right? After that, generator loss. For the generator loss, you have to give the generator loss. The input, what is the input, what is the output? What is the input, what is the output? For the generator, for training, here the generator output means two outputs are there for the generator. What are those two outputs? One is the image. One is the image. This is what we want. But for training, it should go through the discriminator also. So discriminator output is 0, 1. So two outputs are there. So what you have to consider for this? Which output you have to consider for training? Training purpose, not for displaying. For training purpose, not for displaying. For displaying you have to go for image. If you want to display the generated image, then you should go for the middle of that generated image, fake image you can take. But what I want the, whether it is a fake or not, I want to get. So for that also cross entropy, we will go with the cross entropy only. Right? And we can go for the optimizer. Optimizer in general we will use the Adam optimizer in general. And you can try with different generators also. Now what you have to go is, you have to go with this program. Now let us go with this program. In this program what we have done? I think the same program you have opened. This program is also taken from some original paper only. This code is also taken from some original paper. But we have modified that for our data set. Of course, you can open that in your laptops also. First, loading images. Loading images, it is common for any image analysis programs. We have to load the images and we have to generate the code, meaning that the data set, we have to generate the data set. In some codes we will add the labels, some codes we will not add the labels. See here we are just opening, and how we are resizing, please see that. Here I am resizing with 28 by 28 only. I am resizing this with 28 by 28, just a small image, very small image, 28 by 28. Okay, and I have given the comments also. See here the comments. In the comments we can change that to color to black and white to color, meaning that our choice, we can change the choice of the input, whether it is the color image or grayscale image. If you want to work the same model, if you want to work with the same model with the grayscale images, then simply you have to change this. Okay, you have to remove that comment and comment the current one, right? Yeah. Next, here also we can limit the images, how many images you want to read. That is also I have commented that. And finally, what is the output of this? NP dot array of images and label. Label and images will be given, right? And then training data, we are just calling it. And how many images are loading here? Just 2 images here, only 2 images they have loaded. Okay, load the data set. Okay, now see this, rescaling. Here is the rescaling of the image. What we have to rescale? Actually the values are from 0 to 255, from that we have to make it down to how much? From -1 to 1. How can we make it? If you want to scale it with 0 to 1, simply we can divide it with 255. The value is from 0 to 255, and if you want to scale between 0 to 1, simply we have to divide with 255. Am I correct or wrong? Scaling already you have done in the machine learning also, right? Divide with 255. But here what I want is, I want the data between -1 and 1. I want the data between -1 and 1 because I want to use the tanh activation. So because of that reason, how I am doing is, divide by 127.5 minus 1. 127, 255, 255 by 2 plus minus 1, meaning that it will be from -1 to 1. It will give you from -1 to 1. The scaling. This is simple technique, mathematical technique. It is not the GAN concept, it is mathematical technique. Right? And then generator. How we are generating the generator? You just see this. Yeah, this is my generator model. See here, 128 into 7 by 7. My intention is, I want to reconstruct as the 7 by 7 pixels, 7 by 7 images, right? How many images? 128 images in the initial stage. I am taking the random sample here. Actually we can fix this. We can fix this to 100. We can fix this to 200, like that also you can make it, right? And then here also I am using ReLU, all the activations, almost similar I think. So, but here finally the discriminator, I am creating the discriminator also. Discriminator is, see here, input shape is, what is the input shape? IMG shape, I have given as the IMG shape. IMG shape I have created one variable of tuple, okay, and I am adding the convolutional 2D and all these are, I am adding the codes, discriminator. Once the discriminator is completed, here plot generated images. We have to plot the generated images. Where it is available? The generated images will be after the generation of the image, meaning that from the random sample, when we generate the image, there we have to collect. Okay, so for that what we are giving is, we are creating the random sample, random noise, okay, random noise. After that we are generating the images, generator.predict. Please remember this, generator.predict. After that, generated image is equal to reshape. We are reshaping it back to 128 by 28 by 3 because we are taking 28 by 28. Okay, so our generator is generating the images 28 by 28 by 3. So because of that reason I am generating that, and I just want to add that to the panel of the display. Okay, I am just displaying all those images. In the first cycle, I want to display those images. So, for that we are defining this method, and then see here I am giving the image shape is 28 by 28 by 3, channels 3. These are the control variables, okay, and latent dimension is 100. Actually, in general we are not using this completely, we are just using it, okay, and optimizer is Adam, and you can see that what is this parameter in Adam? You say this 0.0002. What is that parameter? Adam of 0.0002. That is the learning rate. I am optimizing the learning rate, I am controlling the learning rate. By default it will be 0.01. Instead of 0.01, I am taking that as 0.0002. Why? Because if I run with 0.01, it is not generating the image because it is crossing the area. So the step is very big. So I want to control that step. So for that learning rate I am changing that to 0.0002. And then, so see here, up to here we are going with that, and then discriminator, we are building the discriminator and then compiling the model with the binary cross entropy, the discriminator, and then generator, we are generating the build generator, and then Z equal to, this is the input shape for the latent space, okay, and then IMG equal to generator of Z. I am giving the latent space with 100. With 100 to I am giving the generator, okay, and then this is only to display what is the shape of the image, and then discriminator dot trainable equal to false. You can see that here discriminator dot trainable equal to false. I am making the discriminator trainable is false. We are making that. Why? Because I don't want to change the discriminator, okay, and then valid equal to, I am taking that valid equal to discriminator of IMG. What is IMG here? IMG is the output of generator of Z, generator of latent space. The output will be the generated image. That's what I am taking, IMG equal to generator of Z, and then discriminator dot trainable equal to false, valid equal to discriminator of image. Now I am calling the discriminator by passing this new generated image. I am connecting the generator and discriminator. I am connecting these two, and then combined equal to, I am creating a new model by combining these two, generator and discriminator. Okay, model of Z and valid. I am taking the Z and valid. Okay, Z is the random sample and valid is the created model, created image. Okay, discriminator output, this is the discriminator output, and we are combining that model. And if you see the architecture of the entire GAN, this is the architecture of the generator. We are starting from 28 by 28, this is the discriminator, 28 by 28 by 3. From that we are generating like this up to 4 by 4 by 256, so that finally we are getting the dense. This is the discriminator, and then generator, we are displaying the generator summary. The generator summary is, it is taking 6272 and then we are reshaping it and regenerating the image by 28 by 28 by 3, and then training step. Here is the training. How can we train the model? So to train the model, we are taking valid equal to np dot ones of batch size. See here is the trick. Here is the trick you have to understand. The batch size I am giving, meaning that in one epoch, first attempt, how many images will be given? Let us say, for example, if you give batch size equal to 32, 32 images will be given as the input. Each image will be analyzed, and for each image there will be the fake or real will be given. Okay. Now in that, what I am giving is, I am generating the ones, meaning that 32 images and ones, all are ones, and 32 fake images, I am giving the 32 fake images, I am giving that value to 0. Why? Because the real images are 1 because they are the real, and fake images I have to give that as 0. I will connect them later in this code. So in the epochs, here I am taking the IDX. IDX means we are generating the random sample here, and image is equal to x train of IDX. Images, we are generating the random images, and noise, we are generating the noise equal to random sample of 0, 1, between the 0 and 1, how many? Batch size and latent dimension. How many latent dimension are there? Those many we have to generate, those many vectors we have to generate. And then generated images equal to generated dot predict of noise. From noise, how many images we have to generate? 32 batch size. What is the batch size? Those many images we have to generate, right? After that we have to calculate the loss, okay, real and fake loss we have to generate, and then discriminator loss we have to generate that, and then generator loss we have to create the generator loss, and then for each 100th epoch I want to display the status, and then for every 100th epoch I want to generate the images. You can see that I am training the model. I will show you the input also. Input images. Serious, these are the input images. I will show you the flower images, what we are giving the discriminator images, original images, how it is generating the flower from the noise. See here, these are the images what I have given, flower images. These are not real flowers. These are also the GIF images, simple images only, generated images, okay. So these are the images what I am giving. Okay, from these images, how it is generating. Where I have been. See here, for first 100 epochs, from the random it is generated like this. This is fake images generated, right? After next 100 epochs, you see the difference. These are the images generated. Okay, there is some point here, flower, it is looking like some flower, right? And after next 100 epochs, it is generating like this. After 100 epochs, I am running this for 1000 epochs. For every 100 epochs I am displaying the images. Of course, there is the loss. Loss will be displayed, that is different case. But what we can understand the image. So I am just displaying the image, whatever it is displaying. See here, after next 100, it is generating the noise again. Meaning that there is one more chance, meaning that again if you train the model same, then you may get good images, or you have to make the model complexity. You have to increase the complexity of the model. What we have taken, I think we have taken 3 to 4 convolutional layers. Instead of that, you can increase the convolutional layers. How can you increase the convolutional layers? If you know this architecture, where you can modify, where you can add the layers, that you can modify that. You can increase the number of layers. For the flower images, it is giving like this. And simply, I want to change the same program. I am not changing the model. I just want to change the data set. See here, I just want to change the data set. Here I have the data set. While loading, yes, no, not here. See here, this is the flower data set. I kept another data set also here. Okay, I will show you that data set. And some vegetable data set is available. Okay, I am just changing that vegetable data set, and I will just run this program again. I want to generate the vegetable, one more vegetable. It may be banana or anything. Here I am taking one type of vegetable, that is banana. I am taking banana, and I am just trying to generate the image, how it is generating. See, it is taking some time to start the session. Yeah, I think it is started. You can also add some more data sets to the same program and you can try it. See here, the data set, it is loaded, the data set is loaded, and the data set is having 75 images, okay, and this is the model. Yeah, still it is running. See here, after 100th epoch, the loss, you can see the loss, how it is changing the loss. 500 epochs are completed. (600 epochs). After 1000 epochs, we will get the images. I don't know how it will be generated. So you have to increase the number of epochs to get the clear pictures. Anyone tried with VAE? Autoencoders? I have given the code, you should try. I am giving the code, you have to execute. You need not write. 800 epochs. You can see the loss. Generator loss. Of course, accuracy is 100%, it is giving. You see how it is generated. Randomly it is generated. Somewhat. Even we are not able to understand what is that actually. So for 1000 epochs, it is not able to generate properly. So we can try with some more epochs. And you can try with different data sets. This model, actually what I observed is, this model is suitable for flower images. If you run for 10,000 epochs like that, it is able to generate some flower. I think you may get in your initial screen of the GAN. If you click on my link, in that link if you scroll down, there are some generated flower images. Have you seen? Last, you will get the generated flower images. I think I ran that for 10,000 epochs or something. The train method has to be run number of times. Only train method. Don't execute run all. If you click on run all every time, it will start from the 0th epoch. Only if you execute the train method, then it will continue. It will carry forward the previous model, previous weights, and it will extend to the next level. Hope you understand. Right? What you have to do is, you have to at least execute this program as it is and try to get the flower images at least, or you can add one more data set to this program and try to execute. Okay, and if you want, you can change the shape of the images also. 28 by 28 by 3 we have given. Instead of that 128 if you give, and if you try with that, then you may get good result. And here if you use ReLU, change that to tan H. If it is tan H, change to ReLU and try with that. We don't know which actuation function will fit for this particular data set. For every data set, pixels are different. Hope you understand. Did you get the concept? Only the thing is, you have to understand the GAN architecture, and at least you should be able to get the code, existing code, and tune that code for our data set. If you are able to do that, we can go for the projects. Hope you understand. Concluding the session for now. Okay, thank you for listening.